Today we're talking about classifying triangles and angles in triangles. Now a lot of this will be review, things you already know from previous years, but we're going to take a little further in geometry. First of all triangles have exactly three sides. If we have triangle ABC, then lowercase a, lowercase b, and lowercase c are the sides of triangle that's named by its vertices, capital A, capital B, and capital C. So triangle ABC has sides lowercase a, lowercase b, and lowercase c. The three interior angles add up to be what? You know it, 180 degrees. So we can say the measure of angle A plus the measure of angle B plus the measure of angle C will add to equal is 180 degrees. Now, a vertex of a triangle, so let's write that in, a vertex of a triangle is the point that joins two sides of a triangle. So here we have triangle ABC pictured, and vertex A joins those two sides, vertex B is where those two sides join, and vertex C is where the other two sides join. The sides across from an angle, the side across from an angle is the opposite side. And that's important when we're labeling the sides of a triangle. So it turns out that the side opposite of angle A is side A. The side opposite angle B is side B. And the side opposite angle C is side C. So we name triangles by their vertices, and we name their sides by the lowercase letter of the vertex that it's opposite of. Okay, so we want to talk about classifying triangles according to their sides. The first type of a triangle is a scalene triangle. I would say most triangles are scalene triangles, which means that they have no congruent sides. They have no congruent sides. Look at the marks on the three sides of the triangle. Each of them has a different mark because each side has a different measure. Okay. Remember, we talked about when we were learning about angles that the same mark means that those angles are congruent. So here the sides all have different marks. They all have different measures. So I would say all sides are different. All sides are different for scalene. And like I said, most triangles are probably scalene. It's special if you have one of our other two cases. The isosceles triangle has two congruent sides. And you can see in our picture, those two sides that both have two congruency marks on each side mean that those two sides are congruent. We're going to learn other fun things about isosceles triangles, but I'll save that for another day. For an equilateral triangle, all three sides are congruent. It has three congruent sides to be equilateral. And you see all three sides have the same congruency mark. They're all three the same. Okay, so let's try using that new vocabulary a little. If we look at this first triangle, I can see that it has two congruent sides. Those two sides are both 8, so two congruent sides. Means this is which kind of triangle? It's an isosceles triangle. Okay, this next one, if we take a look at it, all three sides are congruent. All three sides measure 2. So if we have 3 congruent sides, what kind of triangle is that? It's an equilateral triangle. Hope you have it in your notes because I already covered it up on the screen. Equilateral triangle. Now this last one, remember we said is the most common. If we look at those, we've got a side that's 6, we've got a side that's 7, and we have a side that's 10. All three of those are different, so no congruent sides. No congruent sides means this is a scalene triangle. Scalene triangle. let's take a look at classifying triangles by their angles. So for acute triangles, our first kind that we want to look at, it has 3 acute angles. All 3 angles are acute. So it'll have 3 acute angles. What does acute mean? I think about like babies are cute. A cute little angle is little, okay? Those are our angles that are less than 90 degrees, okay? And so for an acute triangle, all angles are less than 90 degrees. They're all acute. 3 acute angles. Okay, for the next type of triangle is a right triangle, and I'm going to make that box a little bit bigger. It has 1 right angle. And we know right angles, of course, equal 90 degrees, just to clarify. You can only have 1 right angle because a whole triangle sums to 180, and a triangle has to have 3 angles. So you couldn't have 2 right angles because there'd be nothing left for that third angle, okay? So only 1 right angle is all it takes to be a right triangle. The next one is an obtuse triangle, and kind of the same kind of thinking. For an obtuse triangle, it only has 1 obtuse angle. Do you remember what it means to be an obtuse angle? 1 obtuse angle. An obtuse angle is greater than 90 degrees. So I'll put that on the next row so I have a little more room to write it there. 1 obtuse angle, which means it's greater than 90 degrees. Similarly, you can only have 1 obtuse angle because you've only got 180 degrees to split between your 3 angles. So if one of them is bigger than 90, you can't have another one bigger than 90 as well, or it wouldn't be a triangle. It would be bigger than 180. An equiangular triangle means all angles are congruent. All angles are congruent. And we know something more about that. If all 3 angles are congruent, and all triangles sum to 180, if you think about it, that means that if we divided 180 by 3, all 3 angles will equal 60 degrees. Something else really neat about this is that an equiangular triangle will also be equilateral. Like I said, we have so much more to learn about triangles. Today's just the first day of our triangle basics. Okay, so let's try classifying these. Again, make sure you know your vocab. I'm going to scoot the screen up. Let's see what we remember. This first one, my angles are 70, 70, and 40. So 2 of the angles are the same, I notice, but that's not what we're worried about right now. We're worried about that all 3 of those angles are less than 90. It's got 3 acute angles. So it's an acute triangle. They've got to all be acute for it to be an acute triangle, okay? There I see 1, what kind of angle is that? That's a right angle, which makes this automatically a right triangle. And in this last one, all 3 of those angles are marked congruent. If we have 3 congruent angles, then this is an equiangular triangle. As opposed to equilateral triangles are the 3 equal sides. Equiangular is the 3 equal angles. And it turns out that equiangular triangles are equilateral and equilateral triangles are equiangular, but it just is a matter of if you're classifying it by its angles or if you're classifying it by its sides. Okay, now a couple of theorems. This one, like I said, is review. You already know this. The measure of the interior angles of a triangle adds up to 180 degrees. Easy peasy. We know that. So if we have 3 angles, okay, angle 1, I'm going to call that angle ABC, triangle ABC. Then the measure of angle A, like we said on our first screen, plus the measure of angle B, plus the measure of angle C will equal 180. For all triangles. Okay, so let's find the missing angle in our picture. So just a little practice with that. Well, if we know they all add up to 180 and I know two of them, how can I find the third angle? I just do 180 minus the other two. So 180 minus the 115 minus the 35, and that equals, and you can use your small calculators if you'd like, that's going to equal 30 degrees. And that's the measure of angle G, is 30 degrees. Okay, this next one, I've got a right angle, which I know is 90 degrees. So this means that 180 for the whole triangle minus the two we know, 90 and 40, gives me what's left over for the remaining angle, which equals 50 degrees. So that remaining angle is 50 degrees. Some people remember that if this one's 90, that leaves 90 degrees left for the other two. So some people would have worked this by just saying 90 minus 40 leaves 50 for the other angle. Okay, there's always more than one way to work a problem, and that's a correct way to think of it as well. Now, I like this next picture. Now we're getting into the fun stuff, right? So one of the best things about geometry is we can use what we know to figure out all these other things. So the question mark is here in this corner. They'd like to know that triangle, that vertex. But when I look in that triangle, I only know one other angle in it. But I see it's connected to this other triangle. So let's think about what we know in this other triangle. If I'm looking for this angle, then I know that 180 minus the other two angles in that triangle, 35 and 23, is 122 degrees. So this angle is 122 degrees. Now, how is that helpful to me when what I really want to know is that orange angle? Well, what do we notice? How many of you see it? We've got vertical angles here. And what do we know about vertical angles? Vertical angles are congruent. So if this is 122, then that angle is also 122. Now, why is that helpful to me? Because in that top triangle, 180 minus the 122 minus the 27 of the other angle that we already knew will give us that remaining orange angle that we're interested in. So what is that? 180 minus 27 minus 122 is going to be 31 degrees. So the missing angle is 31 degrees. Okay, similarly, let's come take a look at this next one. They want to know this angle way over here, okay? But I only know one other angle in that triangle. So let's start with where we know more information. So starting on the triangle on the left, I know two of the angles. So 180 minus 65 minus 60 will give me the remaining angle in that triangle. So that remaining angle is going to be 55 degrees. Okay, and I like to drop my information in my picture when I figure it out. Now, was that helpful to us? What else do we know? Looking at our picture, I need more information to get I need a second angle in that triangle so I can figure out the third angle. Well, how many of you see it? What do I know about these three angles right here? They form a linear pair. Together, they make a straight angle, and straight angles are always supplementary, meaning they add to 180. So if I do 180 minus those two, minus the 55 that we just found, minus the 50 that was given as the angle in between there, that remaining angle is going to be 75 degrees. So this remaining angle will be 75 degrees because those three together make 180, make a straight angle. Now I'm super happy because now I have enough information to find out the answer they wanted. In this triangle on the right, I know it adds to 180 like all triangles do. So if I subtract the 75 from the angle we just found, minus the 35 that was already given, what's left over is my remaining angle, and that's going to be 70 degrees. So the angle they wanted is 70 degrees. I love it. It just looks like a puzzle. We get to start figure out, use this to get that, and we can get all the way around. So let's try another one. We want to find the measure of angle A here. Now, the measure of angle A in our triangle is this angle right here, x plus 51. And so they would like to know what that is. Well, since the measure of angle A is x plus 51, but we don't know what x is, we need to first solve for x. And anytime you want to solve for x, you just need any equation that's true that involves x, and then we can solve for it. So what's a true equation that we could set up with that would involve x? Well, we know that triangles sum to 180. That's what we're talking about today, right? So that tells me those three angles, x plus 59 plus 84 plus x plus 51, those three angles together equal 180 degrees. So let's solve that equation for x. Let's just combine like terms. I've got x and another x gives me 2x. Then I have 59, 84, and 51. So that'll make 2x plus 194 equals 180. Equals 180. Okay, just subtract 194 from both sides. Just a little algebra here now. And what do you guys notice? Like before I even do that problem, I notice that I'm like 194 is bigger than the number we're subtracting it from. So I've got 2x, just bringing down that 2x on the left. 2x equals 180 minus 194, that's going to be negative 14. Negative 14. Okay, which is fine. Negative numbers exist, right? Like we're going to see them a lot in math. So we learned about negative numbers in algebra. We know them. So it's good to get a little practice with them so we don't forget about them. Okay, let's finish solving that. I just need to divide both sides by 2. And that it gives me that x equals negative 7. Now don't box that as your answer here because go back to your original question. They asked us to find the measure of angle A. And the fact that I have it over here might help me remember that that wasn't my final answer yet. So what are we going to do? We're going to take that negative 7 and plug it in for x in the expression for the measure of angle A. So this was the measure of angle A. So the measure of angle A is going to be negative 7 plus 51. Or 51 minus 7 is usually how I like to think of that, which is just 44 degrees. So the measure of angle A is 44 degrees. All right, we are working now, some serious algebra. Okay, let's look at our last theorem for today, and that's the one that's really new to us, and it's called our exterior angle theorem. And what it says is the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. Remote interior angles. Okay, so let's talk about a little vocabulary. Exterior is outside, so like the exterior of your house is outside of your house, and interior is the inside of the triangle, or just like the inside of your house. So here, if we look at this picture, you can see we have an exterior angle, and it's formed by extending one of the sides of the triangle. Okay, so your exterior angle is formed by the extension of one of the sides of the triangle. So that exterior angle is going to equal the sum, so the measure of angle 1, that exterior angle will equal the sum of the measure of its two remote interior. So there are 3 angles interior to the triangle. 2 of them are remote or far away from the angle that we're interested in. So angle 3 and angle 2, I'll give them both different marks because we don't know anything about them being the same measure. So the measure of angle 1, the exterior angle, is the sum of the measure of the 2 remote interiors, angle 3 and angle 2. Well, why did we have to specify that it was the remote interiors? Because we're not referring to this angle right here adjacent to it. We're not referring to that adjacent angle, okay? But that adjacent angle is important in understanding why this is true, that the exterior equals the sum of the 2 remote interiors. What do we know about that red and blue angle there? The exterior angle and its adjacent angle, those are a linear pair. They sum to 180. What do we know about the red interior angle and angles 2 and angle 3, those 3 angles that make up the triangle also sum to 180. So angle 2 and 3 add to our red interior angle to make 180. Angle 1 adds to our red interior angle to make 180, which means angle 1 must be equal to the sum of angle 2 and angle 3 because both are supplementary to that third interior angle. All right, so let's try using that in some examples. What is the missing angle measure? Well, so they would like to know this angle here, our exterior angle, and our new theorem says that the measure of angle 1, that exterior angle, will just be the sum of the 2 remote interiors. So the 2 remote interiors, I can see them there, are 75 degrees and 45 degrees. 75 plus 45 is 120 degrees. So this exterior angle here is 120 degrees. And to check yourself, because we always like to check our answers, if this exterior angle is 120, then what would the linear pair with it have to be? This one would have to be 60. If I did 45 plus 75 plus 60, if I added those 3 together, would it make the 180 of a triangle? And if I add them up, sure enough, it does. So it checks. It makes the 180 of a triangle, it makes the 180 of a straight angle because that exterior angle is equal to the sum of the 2 remote interiors. All right, let's try a couple more. So what is the value of x? Well, it's the exterior angle, so I know it's going to equal the sum of the 2 remote interiors. So 41 plus 98 equals 139. Now it's important to remember that all of our angle measures need the degree symbol. It's fine if while you're working the equation you don't have them on it, but when you go to box your final answer, you need to make sure you have your degree symbol there. Okay, so let's try this next one. Now, they're taking it up a notch, getting a little tricky here. This time they gave us the exterior angle. It's 119, but they only gave us one of the 2 remote interiors. Can we solve for the other one? You bet you. We know that the exterior angle, 119, equals the sum of the 2 remote interiors, one of which is 46 and the other of which is x. So how do we solve for x now that we have an equation that's true? We just subtract 46 from both sides. And that's going to give us 73 degrees. So x is 73 degrees. And I've got my degree symbol, so we're good to go. Taking a look at this next one. Again, they gave us the exterior angle here is 74 degrees, but they only gave us one of the 2 remote interiors. No problem. We know that exterior angle, 74, equals the sum of the 2 remote interiors, 23 and x. So once I set up an equation that's true, then I can just solve for x. So I'm going to subtract 23 from both sides. And that gives me x equals 51 degrees. Now, of course, we always save the best for the last. Who's ready for an algebra challenge? We're warmed up now. Let's go, let's go. Okay, so this one, we have the exterior angle and the 2 remote interiors all given in terms of x. So we're just still going to follow that same procedure, that same idea. We know that the exterior angle, 14x minus 13, will equal the sum of the 2 remote interiors. One of the remote interiors is 4x plus 13. The other remote interior is 6x plus 2. It's that same idea. The exterior angle equals the sum of the 2 remote interiors. Now let's just do some algebra, combine like terms, and see what we get. 4x and 6x gives me 10x. 13 and 2 gives me 15. And that just equals 14x minus 13. I want to gather my x's to one side, so I'm going to bring them to the side where I have the most x's. So I'll just subtract 10x from both sides. Cancels each other out. That gives me 4x. Now that I have the x's on this side, I want everything else on the other. So I'm going to add 13 to both sides. That cancels that out. 15 plus 13 will be 28. We're almost there. Right now, the 4 is bumped up against the x, which means it's multiplied by x. We undo multiplication with division, so I'm going to divide both sides by 4, and we get x equals 7. Now, is that the question they asked? Yes, they just want the value of x, so we'll box it. Make sure you check before you decide that you're finished. Good luck, have a great day, and let us know what questions you have when you come to class.